Alright, so in this video what I want to do is I want to use the critical number of this polynomial function x cubed plus x squared minus x plus 1 to determine the intervals, okay, the intervals where the function is increasing or decreasing. Now, a function is increasing if its derivative is positive, right, for the whole interval. A function is decreasing if the derivative is negative for the whole interval. So the first thing I need to do is to actually find the derivative of this function. So I'm going to go. So let me actually find the derivative of this function, right? So this is the problem that I'm trying to solve. Let me box it up in red so that we know what we're talking about. So that's what I'm working on, rather. Okay, so here we are. So the first thing I need to do is to find the derivative of the function. Now, so I want to find y prime, where y, of course, is f of x. So y prime. So y prime, well, it's just 3x squared, 3x to the cubed minus 1, so 3x squared, plus 2x minus 1 plus 0, right? Now, the next thing that I need to do to find the critical numbers of this function is find where this derivative is 0 or undefined. Well, this turns out to be a polynomial. So it's not undefined anywhere. Polynomials are differentiable over the whole real line. Okay, so what I'm going to do is I'm going to find out where this polynomial 3x squared plus 2x minus 1, which is the derivative of the function f of x equals x cubed plus x squared minus x plus 1 is equal to 0. So to achieve that, what I'm going to do is I'm going to write 3x squared plus 2x minus 1 equals to 0. Now, I'm going to be honest with you. I don't want to do this by hand. So fortunately, we have Wolfram alpha. Okay, so I'm going to go into Wolfram alpha. Okay, and I'm going to ask it to find whether the derivative of the function x cubed plus x squared minus x plus 1 equals to 0. So notice what I did. I typed dx of x cubed plus x squared minus x plus 1, and then I said equal to 0. So Wolfram alpha gave me the places where this was equal to 0, and I got that x is equal to negative 1 and x is equal to 1/3. So what I'm going to do is I'm going to go, okay, back to my paper. Okay, I know that x equals to negative 1 or x equals to 1/3. And now what I'm going to do is I am going to create a real line. Okay, so I'm going to create a real line. Let me use the color green. Okay, so I'm going to put a real line here in green. Right? And then what I'm going to do is I am going to plot on this real line, okay, the values x equals to negative 1 and x equals to 1/3. All right, so let me do that. Okay, so let me do that. So I am going to assume here that this is 0. So I am going to, this over here will probably be 1/3, and this over here I am going to call negative 1. Okay, so I have negative 1 and 1/3. So now what I'm going to do is I am going to break the domain of the polynomial function Okay, sorry. The polynomial function is x cubed plus x squared minus x plus 1. Now, we know that polynomial functions have domain, the whole real line, right? The whole real line is a domain of a polynomial function. So I'm going to take these 2 points out of the whole real line, and I'm going to be left with open intervals, which I'm going to write down here now. So the first open interval that I'm going to get is from negative infinity to the number negative 1. Then I'm going to get an open interval from the number negative 1 to the number 1/3, right? And then I'm going to get another open interval from the number 1/3 to infinity. Now what I have to do is I have to find points. I have to find points inside these intervals, not the end points. So I'm going to select a point inside the interval, this one, inside this one, any point inside this one, none of the end points. So of course, here, between negative infinity and negative 1, well, I'm tempted to use the number negative 2. Okay, I'm tempted to use the number negative 2. Now, I am going to evaluate the number negative 2, okay, in the derivative of this function. Okay, so the derivative of this function is given here. Let me actually take that equal to 0 out, and I'm going to set this equal again. So I'm going to get the derivative of this function, okay, and I'm going to evaluate the derivative of this function, which is equal to 3x squared plus 2x minus 1. Okay, let me actually copy this derivative, okay. I'm copying the derivative. Here it is, negative 1 plus 2x plus 3x squared, okay? And I am going to evaluate this, okay, at the number negative 2. So what I'm going to do is type in here where, okay, x equals to negative 2. Now, Wolfram alpha is going to give me the answer of what happens to this derivative when x is equal to negative 2. So let's see what we get here. So when x equals to negative 2, we get the number 7. Now this is a positive number. The number 7 is a positive number. So right away, sorry, I'm not upgrading to Pro yet. Okay? So because I got a positive number here, that means, okay, that means that because when I evaluated the number negative 2 here, okay, and I got a positive number, right? So I chose the number negative 2 here, and I got a positive number. That means that the function is increasing in this interval between negative infinity and negative 1. Now over here, I have to select another number, right? So I have the function, okay, so I evaluated the derivative, and at negative 2, I got a positive number, so I concluded the function was increasing in this interval. Now what I'm going to do is evaluate at a point in this interval of my choice, so I'm going to choose the number 0 in there. And I am going to evaluate the derivative at 0, and I will see what I get. If I get a positive number, the function is increasing in this interval also. If I get a negative number, the function is decreasing in that interval. So let me actually plug in 0 in here. So when x is equal to 0, let's see what I get. I got a negative number. I got a negative number here, the number negative 1. Therefore, the function is decreasing over this interval. So decreasing. Okay, because it is negative. And the next step is to choose a point inside here, inside the interval between 1/3 and infinity. So here, I guess I could choose the number 2. I could choose the number 5, 7, 8, any number you wish. But I'm choosing the number 2. Okay, so I'm going to go back here, and I'm going to type when x equals to 2. So let's see what happens in there when x equals to 2. So I click equal here, okay, and let's see what I get. Now this is the derivative of the function being evaluated when x is equal to 2. I got the number 15, okay? So I got the number 15 because that number is positive, the number 15, the function is increasing in this interval. So now I have broken the domain of the function into intervals where the function is increasing, decreasing, and increasing. And in order to achieve that, what I did was I used the critical numbers, okay, and to get the critical numbers I had to use a derivative, right? And then what I did was I evaluated the derivative on values, okay, obtained from the critical numbers in the domain of the function. And that told me where the function was increasing, decreasing, okay. Sorry, this over here should be an I, increasing. It looks like a D, increasing. Okay, so so thank you for listening, and this is the way you do these kinds of problems. Okay, so